Okay, we're back. This is Techmath2. We're looking at review for chapter 9-10. This is part 3. All right, so multiplying when it's in polar and then leaving it in polar. These are pretty basic problems. So it's 9 times 6 is 54. So you just multiply the r times the r. And then to find the angle, you just add the angles. So that's 100 degrees. And then you're done. So, whee, an easy one, finally. With division, it's you take the r's and divide them. So you pop in 8.5 divided by 1.7. That happens to be a whole number. That's 5. That works out exact. And then to find the angle, you subtract the angle. Now this is a little tricky because it's a negative on the bottom, but it would be 75 degrees minus negative 25 degrees. So because it's minus a negative, remember that means plus. So that's 100 degrees also. So these, compared to the last one, 20b that I did, these are a walk in the park, right? These are pretty easy. Same dog, different fleas here. 3 divided by 4 is 0.75. And then 120 minus 40 is 80 degrees. Except this one, they want a little extra effort. They want it in both polar and rectangular form. So we've got polar. We're done with polar. To get this into rectangular form, you could do, polar to rectangular x, 0.75 comma 80. And that'll kick you out 0.13. If you don't like it that way, you can say 0.75 cosine 80, and that will also give you x, all right? So we got 0.13 plus polar to rectangular y, 0.75 comma 80, is 0.74. And if you don't want that, you could do y is equal to r 0.75 times the sine of 80 degrees, and that will be 0.74. So that's 0.74 and then j. Don't forget to put the j there. Okay, and that's it. So that's polar, that's rectangular. Oh, this one is a little tough again. So we went from super easy, like 21, to pretty darn hard 23. Let's take a look at 23. It's a little involved again. Electricians use these formulas for resistance in a circuit, and definitely engineers use a lot of imaginaries. That came up about, a student asked about where are imaginaries used. So any kind of aerodynamics uses almost exclusively complex or imaginary numbers. Electrical engineering, anytime there's a capacitor in there somewhere, something that holds and discharges a charge, you're going to utilize complex or imaginary numbers. And even for electricians, for resistance in a circuit, you use the imaginary number system. All right, so let's take a look, shall we? We've got I given as 45 degrees, z sub 1 given as 0 degrees, z sub 2 given as 20 and 30 degrees. So this first part is easy peasy. We do the distributive property, and so 2 times 40 is 80, and then 45 plus 0 is just 45, plus 2 times 20 is 40, and 45 plus 30 is 75 degrees. So that was easy. Unfortunately, we still have to add these. So now we've got to convert these back to x and y, and these are not easy conversions. So we're going to go okay, because it's a 45, 45, 90, it's 56.569 and 56.569. So x and y are the same because it's an isosceles triangle, essentially a 45-degree triangle. All right, so this, though, is, again, not easy. So from polar to rectangular x, 40 comma 75, and polar to rectangular y, 40 comma 75. And so we get 10.353 and 38.637. So now we can set it up as parenthesis 56.569 plus 56.569j plus 10.535 plus 38.637j. And so we add those together, the like terms. And so we end up with this. V is equal to 66.922 plus 95.206j. And now we're still not done because they want it back in polar form. So now we have to go from rectangular to polar R, 66.922, and from rectangular to polar theta of 66.922, comma 95.206. Oops, I left that off over here, comma 95.206. Okay, so R then is equal to 116.37, and theta rounded to a whole number is equal to 55 degrees. So our final answer is 116.37, and then that crazy big angle sign, 55 degrees. Holy smokes, that was a lot of work. So there is going to be one sort of like this on the test, but it won't be this involved. It'll be an easy one to convert, not a tough one, not like this. These were really ugly. If I give you like 0 degrees, 90 degrees, 180 degrees, they're super easy to convert. So it'll be a little more like that, okay? And not quite that involved. Whew, that was a lot of work. All right, let's take a look at the last one on the review. And that's going to be 24. And so one of these is pretty easy to solve. And one of these is a little more involved. So 24, we got 5x squared plus 10 equals 0. This one's easy to solve. So because there's only a single variable, we can isolate it. Even though it's a second degree, divide by 5. X squared is equal to -2. So x is equal to plus or minus the square root of -2. And now plus or minus, that's 2j squared. And so now you take the square root of 2, that's 1.414. So plus or minus 1.414j. Or if you wanted to do it as two separate answers, 1.414j. Oh wait, they only want hundredths. 1.41j and -1.41j. Okay, so two separate answers. All right, and then the last one, we have to go back and use quadratic formula. Remember, A is the thing in front of the x squared, so there's a 1 there, 1. B is the thing in front of the x, that's -5. C is the thing without a variable on it, that's 8. And then you just plop it into this formula. A squared is 4ac all over 2a. The opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Quadratic formula, and plug and chug. Okay, and so What is that? 5 plus or minus the square root of 25 minus 32 all over 2. That is 5 plus or minus the square root of negative 7 all over 2. That is 5 plus or minus the square root of 7j squared all over 2. And so the square root of 7 is 1.32. Or no, it isn't. It's 2.65. So x is equal to 5 plus or minus 2.65j all over 2. And then if you divide the 2 into both of them, you end up with 2.5 plus or minus 1.325j. So a little tedious, but I think number 23 takes the cake as the hardest problem on the whole review. All right. And that is what the test is gonna look like.